Let us begin the part 2 for resolving vectors. So resolving vectors part 2. Let us take an example here. Now we have seen in the previous class that you can resolve a vector into its horizontal or vertical component. So if this was F for some reason, let's say F force, and if this is angle theta, then this is your F cos theta, and this is your F sin theta. Now we are going to have different examples here and then we will discuss. So let us say first example. Let us take example 1. So example 1. Okay. In this example, we will take an inclined plane here. Okay, so we will take an inclined plane here. So I'll just insert a shape here. Let's say I will insert a triangle here. Okay, something like this. And I will just format it and I will remove the color, no fill. Okay, close. Fine. Now let us begin again. What we are exactly going to do is we are having an object here. Let's say this is a object. Okay, and this object has its mass which is completely acting down as weight in this direction. Okay, so this is your weight, and weight is nothing but, we know, it is mass into acceleration due to gravity. Now what we are going to do is we are going to just draw a line like this, and then if this angle I'm taking as theta, then this is also theta. In that case, if you look at this angle, this side which is coming down here, this arrow, this vector, and the vector up, now this vector is called, top one is called here as your normal reaction. So this is your normal reaction. Now there are two more here. If I draw them also, then there is one which is directed downwards and there is one which is directed backwards, like this. Okay, so you have 1, 2, 3, 4. If I resolve this theta and this weight, then I'm going to get here W cos theta. See this component. Why? Because this side which is touching the angle is the adjacent. So for adjacent you get cos component. Exactly same way I'm going to write this also. This will be my W sin theta. Why? Because opposite to theta is this side. See this side, this one, and this is parallel. Both are parallel here. Okay, so since the opposite represents this vector, therefore I can write W sin theta, this theta, which is opposite this one. If you look here, this opposite. Now there are so many possible cases. One case can be if the box is moving down. Okay, so let us say case 1. Case 1, if the box is moving down, and the force of friction is 0, let us say. Okay, no friction. In that case I can write the force responsible for the box to move is horizontal component, is w sin theta, rather, let us write that, is w sin theta. So we can write that w sin theta itself is equal to ma, or in other words we can write mg, which is your weight sin theta, is equal to ma. I can just cancel both the m's, right? In that case I will get the equation as, therefore, g sin theta is equal to a. Now if you look here very carefully, as theta becomes 90, your g becomes equal to a, right? So we can do even an experiment here. We can do an experiment which was actually done by Galileo, and he plotted a graph between theta in degree and acceleration in meter per second square, and for that graph he got it as a straight line. As theta was increasing, this also was increasing, so he got an equation here, y is equal to mx plus c, where y is acceleration and x is degree. In other words, a is equal to m theta plus c. Since your c is 0, so you can find out the value of a when theta is 90. Okay, so therefore at theta equal to 90 we get a equal to 9.81 meter per second square. So maybe you can verify this using experiment also. Okay, so this is your case 1. All right, now we are going to discuss case 2. Let us see case 2 now. Okay, I'm moving down. Okay, now in case 2, if friction acts backward, which means on this slope where you are having the object, you now get this one as your force of friction, and this is your, as usual, w sin theta. This is your normal reaction. Okay, normal reaction, and this is your w cos theta. So we can now write, if box is accelerating down, then we can write your w sin theta minus force of friction is equal to ma. I hope you know that this ma is actually the resultant force, is actually the resultant or the net force. Now this is one equation. Also, both 1 and 2 we have the normal reaction n, which is equal to your w cos theta. Okay, this is another equation. So this is how we actually solve the question. Now this is a case where you can do an experiment on this also. You can do the experiment you can do by changing nature of surface, so that force of friction, this is force of friction, by the way, this is force of friction. Ff changes. Hence, we can study how it affects the acceleration. There are so many ways you can study. You can even change the mass and try. Okay, so there can be some question. Like question is, if mass of object is increased, then will it affect the acceleration? The acceleration. Okay, think. This is for you to think. So think and answer. Okay, if you have doubt, you can just email me at this address. Okay, sudeeptanin at gmail.com. That's it. So gmail.com. Just send me here and I will tell you the correct answer, right answer. Okay, thank you.